Yes, ma'am.
Yes, sir. Himmat sir, our speaker is with us. So kindly please proceed. Welcome, Himmat sir.
Thank you very much, madam. Hello.
Himmat sir, good afternoon.
Good morning, sir. Very good morning.
Good afternoon, sir. Sir, we warmly welcome you
Okay, thank you
after
very
the
much,
lunch
sir.
session. Uh,
Okay.
we would like to introduce to Sir Dr. Himmat Sarvaiya is a faculty uh, is a faculty member in LE College of Morbi, and his educational qualification is PhD in Soil Mechanics and Foundation Engineering from SVNIT Surat. His master's is from the same field, and he is a Bachelor's of Engineering Civil Engineering from SS Engineering College, Bhavnagar. Uh, Sir is a very dynamic profile and have a wide range of work experience, right from teaching that is of about more than 5 years, uh, and 1.5 years of experience from private college, and about 5 years of experience in LE College of Morbi. He is having geotechnical consultancy work experience in the field of applied mechanics. Uh, he is having field experience on building planning, architecture, interior design, building execution, supervision, quantity and quality analysis. He has an experience from Bhavnagar Municipal Corporation building department for about 6 months, and he has an experience of consultancy work in geotechnical engineering from SPNIT Surat. He had been a full-time research scholar in applied mechanics department in SPNIT Surat. He had delivered many expert talks, some of which are titled as Experimental and Finite Element Studies on Geosynthetic and Enclased Floating Stone Column. Uh, he has also delivered southern lectures on soft soil improvement using stone column technique, and he has a wide range of publications which include dozens of scoopers and international journal papers. I would ask Sarvaiya sir to start his session. Uh,
Okay, sir.
Sarvaiya sir.
Okay, sir. Thank you very
Yeah.
much.
Thank you.
Uh, Thank you, Nikun, sir, for giving a brief intro. Uh, First of all, I would like to thank you, Professor Damyanti Madam. He is a very dynamic person. Since I know we are in the PhD research scholar at SVNIT Surat, I know that Damyanti Madam as a very dynamic person, whether it is laboratory work or presenting papers at international or national journals. Uh, she is one of the best PhD research scholar in SVNIT since my time, as I know. Uh, since the SVNIT is a research hub, a few experience I would like to share after the this presentation. Before that, I would like to share some of the knowledge to improve the soft soil. So uh, I can start, sir, my presentation.
Yes, sure, sir. Yes, yes.
Okay, okay, ma'am. Okay, is it visible, ma'am? My screen
Yes,
is
sir,
visible.
perfectly, perfectly.
Okay, thank you very much. Okay, good afternoon, all students and my colleague. This session, I will stick to the soft soil improvement using stone column technique. Uh, this stone column technique is a versatile technique to improve soft soil. Right, this technique, I will explain how this technique work in field and what are the researches going on in laboratory as well as in analytical means. How can we analyze stone column technique? So various research is going on technique. However, some of the advantage disadvantage connected with this technique, but moreover, this technique is a most useful and rapid technology that will be see during my presentation. First, this slide I will start with the basic. Then I will explain different techniques and its advantages and what are the research is going on this technique. And if student are interested for higher study, say for PhD or MTech, student will be beneficial to learn this technique as a laboratory research as well as in the software based research. Right. So talking about this technique, basic overview, as you see in graphical presentation, that stone column is a aggregate pier. Aggregate, that means whatever we using in reinforcement work, that is aggregate 20 mm to 40 mm size. So stone column is an aggregate piers or array of crushed stone pillars placed with vibratory tools. As you can see in this picture, the aggregate is placed with the vibrating tool below the soil surface. This method is also called ground improvement by vibro replacement stone column. Vibro is the this instrument attached here. This vibratory probe is called vibro. So this technique is very useful for certain civil engineering structures for rapid construction of work. We will see later on some of the case studies where this technique can be applied. Okay. As this technique is a aggregate pier, we have to put stone aggregate inside the ground. This can be achieved by certain means that we will discuss, but here you can see the step-by-step procedure. How can we construct stone column at site? First slide graphical representation. Here you can see a vibro vibratory probe is called vibro. There is a certain types of probe available in market, but here in picture you can see the aggregate also transfer from top to bottom at the vibro probe. There are certain holes through that you can transfer material aggregate as well as water. You can also transfer by pressurized means. So the first step for creating stone column is to create a bore hole. Bore hole by means of this vibratory or some certain means. We will explain in next slide how can you prepare the bore for this stone column. So first step is to create a bore hole. Then second step to transmit aggregate or to feed the aggregate. So there are certain method whether you feed the aggregate at the bottom of the vibro float or from the top of the vibro float. That we can see different method in later on. But this is this certain technique that first you create bore. then feed the aggregate, and the compact the aggregate by vibrofloat, just lifting the vibrofloat and impacting that aggregate so that the compaction can happen, and the finishing layer. Right, this is the basic technique. This is bottom feed technique. We will see what are the types of technique later on, but this is the basic technique. We can create the aggregate pier or stone column at site. There are huge instruments, accessories available with Kellers and other companies that we will discuss later. As the stone column, for preparing stone column, we need to excavate, we need to create a bore at site. So that bore we can create by two means. First, by injecting water into the ground, turning the soil into slurry and flushing out from the hole. That means a vibratory probe which having a water jet at the bottom, we have to uh, vibrate the vibrofloat, and meanwhile allowing water jet to loosen that soil. So whatever the loosened out the soil will come out at the top. And after on, once we created borehole, we have to feed the aggregate from the top. Here you can see. So this technique is by vibro floating technique. This technique is just developed by Keller Company, Germany in 1930. First developed, very recent technique. There is no future, the past. It is made by Keller Company. Vibrofloat technique is made by Keller Company just in 1930. Since now, almost 80 years, we are using such technique in India also. This company is working in India, very mass structures creating by the Keller Company that we'll discuss in case studies also. So vibrofloat, here you can see actual pictures are vibrofloat. We have to create the borehole at different spacing. What spacing we should maintain, that we'll discuss. But here you can see the two vibrofloat are excavating the bore. Here you can see the jet at the bottom. So jet will help to loosen the ground. Right, different technique is used for different type of soil that we'll discuss, but here the specific type of soil is used as a clay or silt. Right, so for clay and silty soil you can use vibrofloat. uh, Another method for creating borehole is by drilling a hole into the ground by drilling accessories. So in that technique, what we have to do, first create a borehole by drilling accessories and then feed the aggregate. Right. So both the way we can create the stone column and rest our structural load or structure, civil engineering structure over this soil. The basic principle is to increase the density of soil and to increase the permeability capacity. So the whatever liquefaction or other parameters we can neglect, what are the damaging our structure. So talking about these two technique, borehole creation by vibrofloat and by the auger. There are different types of auger that you are already aware. So here any auger, mechanical or man-made auger, you can create a borehole, then feeding the stone into the ground up to the required depth. So we can create the borehole likewise. So basic principle of vibro compaction stone column is to increase the density of the ground by entering some of the non-cohesive material. Right, non-cohesive material is very good at the bearing capacity aspect. So that material is aggregate gravel or stone, crushed stone, we can add to the borehole and compacting that. So our ground will ultimately the capacity will increase by increasing the density of the soil. So vibratory probe, what happen? The ground will shake. Whatever the area surrounding by vibrofluid is shaken, so repacking of soil particle will happen. So whatever the permeability coefficient will reduce, and meanwhile density also increase for equal volume. So This is the basic principle that we create a borehole by increasing the density of soil, so the bearing capacity is increased. How much bearing capacity increase, that we'll see from later research papers. So what happened by creating such stone column? You can increase bearing capacity, increase density, decrease settlement, provide lateral stability, increase resistance to liquefaction. So these are the advantages we will discuss later on. How you can, how the bearing capacity of soil is increased. Now talk about the different methodology used in the field, how we can create the stone column. There are two main categories: non-displacement method and displacement method. In non-displacement method, what we have to do, we have to create a borehole, then feeding the aggregate and then compacting. Here soil is not displaced, that means we creating borehole, whatever the soil is removing from the borehole, then we feed the aggregate. So this is called non-displacement method. It is also called bore ram. Bore ram, that means we create bore and feeding aggregate and ramming the aggregate, so enlarging the area, so the bearing capacity will increase. This is the non-displacement method. And other method is displacement method, or displacement method is also called Vibro replacement method. In that there are two categories: dry bottom feed technique and top wet feed technique. What the technique, what that means, we will discuss in next slide. But in Vibro replacement, there are two techniques: dry bottom feed and top wet feed. What is dry bottom feed and top wet feed? Here you can see the picture: top feed system, top wet feed system. That means what? We are allowing aggregate from the top of the surface. Here you can see vibratory probe creating the borehole, and we are allowing aggregate from the top. How the aggregate travel at the bottom? So vibratory effect, as well as gravity action, as well as settling property. Because this vibroport having a water jet at the bottom, some vibrofloat also have a water jet at surrounding this vibrofloat, right? So creating borehole is much more easy by vibrofloat. Then we feed the aggregate from the top of the surface. This is why we create the stone column. So this is called top wet feed. Why top wet feed? Top, that means we are allowing aggregate to reach at the bottom from the top, right? We are feeding aggregate from the top. Water jetting is help that aggregate to reach up to the required depth by vibratory action. So whatever the clean stone column, whatever the clay material or cohesive material will wash out at the top during the vibro float borehole creation, right? Material will sprout at the top, whatever the cohesive material which is very sensitive or which is very highly settlement material. Clay material is highly sensitive in the case of settlement property of the soil. So that material we can remove from the vibrofloat, washing out that loose material, and we create the borehole with the non-cohesive gravel or crushed stone material. So this ground is very hard compared to loose ground. Talk about the other technique, bottom feed system. Bottom feed system is why it is called dry bottom feed, because first a vibrofloat, here you can see left side in the middle of the figure, vibrofloat is creating the borehole, and whatever aggregate is feeding at the bottom, we have to put that aggregate into this vibro float. This probe is travel the aggregate at the bottom. No water jet is required here. You can see bulldozer here is feeding the aggregate, crushed stone aggregate, at the top funnel of the vibro float, and meanwhile it's travel up to the certain depth, whatever the depth we required for to create the stone column, this travel up to the certain depth. So this is called dry bottom feed method. Here dry, that means we are not required water to create a borehole and to transmit the stone column. It is directly transmit up to the bottom by vibroflow. That's why it is called dry bottom feed method. So depend on soil type, depend on material availability, depend on the accessories, machinery availability, we can create the stone column by different methods. That we will discuss later on if any doubt. So this technique nowadays is a automatic technique. You can measure the depth of the stone column or the diameter of stone column or the density of the material, right? All each and every parameter is you can measure inside the truck by automatic measuring system. Here you can see, right? It is attached inside the cabin. Whatever the depth you achieve, what is density, what is improvement achieve, what volume of aggregate is feeded till now, that you all dynamic parameters you can measure from inside the truck also. So very rapid technique. All parameters is measured, even the bearing capacity, how much ground is improved, that you also can measure inside the cabin, meanwhile dynamically, right? So this technique is very versatile. Now in foreign country it is also used. In India also, certain Keller company is very aggressive in India, is working in large project, government project and semi-government project. Keller is used for ground improvement techniques, right? Now talk about the factor influencing the design of stone column. What are the diameter, what are the size, which factors are effective or which are the affecting the stone column technique, is we can discuss that soil type. First of all, soil type is very important parameters by constructing stone column. So we have learned vibro compaction and vibro replacement. There are two techniques. Vibro compaction, in that we have to vibro compaction, that means ram column. You create the bore, feeding the aggregate and compacting that aggregate. That is vibro compaction. While vibro replacement, we creating borehole with the dry feed or bottom feed technique and feeding the stone column. Meanwhile, we also compacting that aggregate also, right? So this technique, stone column technique, is highly depend on soil type. Here you can see vibro replacement stone column is effective up to the clay, silt, sand, gravel, stone, up to the stone, vibro replacement, while vibro compaction is up to the sand level. If there is a very loose soil, cohesive soil, then vibro compaction technique cannot be used, because what happen during the stone feeding, if we apply if we apply impact on the stone column, whatever aggregate will uh, whatever aggregate we are feeding in the stone column hole, whatever we created the bore hole, that will uh, move to the surrounding soil. It will not create the confinement. Soft soil will not create the confinement, right? So this technique vibro compaction is limited up to the stand level, while vibro replacement is used up to the clay level. Vibro replacement technique also some limitations. Beyond clay level, there is organic matter. So such type of organic matter or very sensitive soil, sensitivity less than 4, is not we cannot treat by these two method, vibro replacement or vibro compaction. So this is basic. Soil type is depend on the design characteristic of stone column. Initial soil strength, as we discussed, that soil parameters is highly dependent on this technique. Sensitivity less than 4, we cannot treat with vibro replacement stone column technique even, right? So this is limitation. But such limitations we can neglect. We can see how we can use that stone column technique even though sensitivity is less than 4. then we can learn in later on slide. Probe spacing and pattern. These parameters in vibrostone column always we are constructing in group, right? In like pile group or etc. You have learned already. Vibro compaction, vibro replacement, stone column is always creating in group. Say for example, if we construct a building, then 10 by 10 meter building, then we almost construct 100 stone columns at different spacing. What spacing we should maintain, what diameter we should maintain, that will learn in design parameters. But we are discussing here which parameters are influencing the design of stone column. First we see soil type, the soil strength, initial soil strength. If soil strength less than 4 sensitivity, then we cannot read. Then probe spacing and pattern, vibrofloat spacing. Here you can see the dotted area is a stone column area, whatever we created, but its influence, whatever the we inserting the stone column, its influence up to surrounding circumference, right? So that influence is around the stone column diameter. That diameter, whatever the influence around the stone column, is called equivalent diameter. What is equivalent diameter? We will, and what we can keep that diameter, we can learn later on. But spacing and pattern all are depend on stone column designs. If spacing is more, your the bearing capacity improvement is less. Spacing is near, your bearing capacity is more. But how much spacing we should maintain so that our work should be smoothly work at site, as well as no more cost. Cost is project cost is also affect on stone column technique, right? Whatever the spacing we maintain, that is directly related to the project cost. So that we have to take in consideration, that spacing should be as needed as required, right? This whatever the spacing required, that we will learn in next slide. Sensitivity of soil which is more than 4, that cannot treat with stone column. UCS strength not less than 0.7 ton per meter square, which cannot be treated by stone column. This is limitation of this technique. Cross stone column, cross stone should be used. Whatever we are using of replacement material, that material should be a cross stone. Cross stone which having no clay material contacted, so this material is ideal for stone column. This material should be chemically inherent. Wherever chemically inherent, that means chemically not active aggregate should be fit. Size should be maintained. Aggregate size is highly dependent on the successful working of stone column. So in field, generally 20 to 40 up to 50 diameter stone we generally use. So one basic criteria you should maintain, that stone column aggregate should not as large and should not as minimum, so that whatever the function or creating stone column method should be easy. If more large dimension of aggregate if used, then there may be more cavities and you cannot compact such aggregate. So there is certain limitation of diameter or size of the material, backfill material. Well graded of 75 to 2 size may be used. Well graded aggregate cross stone is better for the stone column technique. Now move on to the basic parameters, basic design parameters. First, stone column diameter. Which size of stone column we should create at site, right? So this is the first design parameter, that you should create a stone column in generally in field 2 to 4 feet of diameter generally used for vibro replacement technique, while ram stone column we can create up to 1.5 to 2.5 feet diameter. Depth according to required, right? So in field, 2 to 4 feet generally using vibro replacement technique, we can create up to 2 to 4 feet diameter stone column. Because there is instrumentation availability limitations, we can create such diameters. If you have such other than this diameter instrument, you can create different diameter also, right? But in generally, what your availability of instrument, we can create 2 to 4 feet diameter in the case of vibro replacement, and 1.5 to 2.5 in the case of ramstone. But while considering the diameter of stone column, the stone column diameter, actual stone column diameter, is always larger than the probe diameter. Here you can see the probe diameter may be assumed as 100 centimeter. So whatever stone column may be around 200 centimeter, right? Because a vibratory probe having a vibration area, surrounding area, is larger than the probe diameter, because we create the borehole. So that borehole we can create by the vibration action and water jetting. So whatever bore we have created is always larger than the vibro float or vibro this probe, right? This consideration you should keep in mind during the actual construction. However, the diameter is also depend on soil type, UCS strength, stone size, whatever the feeding material or replacing material we are using, that size also depend, right? If your aggregate is very larger, then your stone column diameter should be more or larger. So that you have to consider. Second parameters, design parameter, you should consider as a spacing. Which spacing is ideal for stone column, right? So spacing is directly related to the cost of the construction, as well as the improvement of stone column technique. More spacing, less bearing capacity. Closely spaced, more bearing capacity. But you cannot place stone column one by one, near by near. There is certain spacing required, because once you insert the stone column, there is an influence area surrounding it. So if you insert stone column near about influence area, then there is a difficulties to create the borehole, as well as to create or to feeding the stone column. So there is a certain spacing you should mention. So what diameter you should kept in mind? That is equivalent diameter. So up to equivalent diameter, your stone column must be spaced up to the equivalent diameter. Here you can see DE. In the case of triangular pattern, what is the pattern of stone column? We will discuss in next slide. Here you can see triangular pattern. So in the case of triangular, equilateral triangular pattern, you have to keep that equivalent diameter up to 1.05 S. S is the spacing, right? In the case of square pattern, equivalent diameter is furthermore 1.13 S, right? So here you can see here factor is 1.05, here factor is 1.13. So you can see DE is equal to 1.05 as stone column created by equilateral triangle pattern will give you the more compact stone column at the field compared to square pattern, right? So this stone column will be more closely spaced stone column in the case of equilateral triangular pattern. However, in the field, general spacing of stone column is 5 feet to 11 feet. Normally, not more than 4 times diameter. If your diameter of stone column is 100 centimeter, then you should be place other stone column up to 400 centimeter. Not more than 400 centimeter. This is the basic parameters we should keep in mind while constructing stone column at field. Stone column pattern. As we discussed in previous slide, stone column can be created at the site with different pattern. you can use triangular orientation, square orientation, hexagonal orientation, right? Depend on the orientation, you can find equilateral diameter, equilateral the diameter you can calculate from this equation, right? So which technique is more useful? That if the d is very less compared to these three technique, if d equilateral diameter is very less, this technique will give you the best possible compaction of ground, best improvement if this de is minimum in from this shape. So this d will be very minimum in triangular shape, right? So triangular orientation is best possible solution for the ground improvement. The spacing, diameter, height of stone column is depend on the availability of soil layers at site. Before constructing stone column, there are certain tests, certain methodology used to find which soil is available at which depth. So this technique we have to use before constructing the stone column, that available soil without improvement, what is its bearing capacity, right? So at each and every depth, which type of soil, which is bearing capacity, you have to measure before stone column introduce. And then after introducing stone column, you can measure that how much ground improvement is taken place. There are certain technique you can create, you can take a that stone column pile load test, plate load test, or you can use the under bore probe method. There are certain techniques also available, but from that technique you can see that the ground improvement is improved by inserting stone column, right? So these are the design parameters, stone column pattern, which pattern is useful that you learn. Because compared to other technique, you can create a different technique by different pattern, but you should keep in mind that this technique, whatever the this equivalent diameter is minimum for equal diameter of probe. If the equilateral diameter is minimum, that spacing, that pattern is best for your stone column technique. Now, other parameters which is influencing stone column is area replacement ratio. Area replacement ratio is the ratio of area of stone column divided by area of surrounding clay. That means how much stone column aggregate you feeding into the ground, right? For example, there is 100 square meter area. In 100 square meter area, out of 100, you create a stone column of about 25% area you feeding stone column. So your area replacement ratio is 25%, right? So in field, stone column, by stone replacement technique, stone column area replacement ratio is generally 15 to 30%. I'm giving the example that your stone column should be, if there is 100 square meter area, in that if you construct your stone column by covering 30% of area with stone column, then your area replacement ratio will be 30%, right? Which is highly recommended in site. So area replacement ratio should be 15 to 30%. A large ratio is required to have significant reduction in settlement. Large ratio, that means 30% is enough. Above 30% is good, but there may be effect on cost of the project, right? Because the spacing will reduce, the depth, compaction, effort will increase. So area replacement 15 to 30% is ideal. Types of soil suitability for stone column. That slide already we have seen from previous slide. That vibro replacement will be used up to the clay soil. Beyond the sensitivity 4, we cannot use even vibro replacement technique. There is certain improved technique available in field that we'll discuss, but there are certain limitations. So this technique is ideal in the case of silt, sand, and gravel. It is non-cohesive material, which material that gives you effective confinement surrounding the stone column, which is ideal. But if there is a organic matter or clay material, if you construct the stone column in that, what happen? Whatever the load coming, aggregate whatever we feed it is displaced into the surrounding soil. So your stone column may be fail. So types of soil is highly recommended for stone column is silt, sand, gravel. Even though this technique, stone column technique, is highly recommended, but if not take proper care, this technique may be fail. Stone column even though fail by if we applying more loads. So stone column may be fail in different three failure mechanism. One is bulging failure, right? Or short column. If long column is constructed at side, this stone column may be fail in bulging, right? Or short column may fail in shear, or it may be fail in punching. So depend on soil availability of subsurface soil, stone column is fail in different condition. If there is a hard strata available at the tip and load coming from the top, stone column will fail in bulging. If there is a loose soil and short column is available, it will be fail in shear or maybe punching. So this, whatever the failure mechanism I am talking here is available in IS 15284 part 1, that is design of stone column. The special code by IS Indian Standard Code 15284 part 1 2003 is specially designed for the stone column technique. How stone column fail, which diameter you should maintain, which spacing should maintain, what depth should be enough, right? All that design consideration is guidelines is available in IS code. So for column having length greater than its critical length that means 4 times D. If the diameter is D, then 4 times diameter is your critical depth. What is critical depth, that will explain later on. But bulging happen in long column, bulging happen, the maximum bulging at the 2 times diameter of stone column, that you have to remember, so that in next slide is that use I will use that critical depth as well as bulging phenomena in later on slides. So whatever bulging happen in the stone column at 2 times the diameter, if diameter is D, then maximum bulging happen at 2 times diameter. Bulging, that means whatever load coming over the stone column is expanding its material into the ground. Now, why this material is expanding at the top? Why not expanding at bottom? Right? So this is the basic question, that at top of the surface, there is a less confinement of soil. At the bottom, there is a huge confinement. The confinement stresses at the top is very less. It is very less up to the 2 times diameter. So stone column will expand its aggregate into the soil up to the 4 times diameter, that is critical depth. Beyond that, there is no bulging. So whatever bulging occurs up to the 4 times diameter because of less confinement at the top surface, right? If you go inside, inner and inner, the confinement is more and more. So stone column, there is no bulging effect, right? So bulging happen up to 2 times diameter maximum, and it will be lead up to the 4 times diameter. So this way a stone column is fail at the field if the design load is increased. Say for example, you have to construct a building up to this 100 ton. If future load is increased more than 100 ton, say 200 ton, then your stone column will expand up to the ground. Surrounding aggregate will expanding into the soil. So this way stone column will fail, right? So this is the limitation, that if the surrounding confinement is very less, this technique is not suitable, right? So this technique is suitable if this confinement surrounding stone column is very high. This will be very useful technique. So many researchers have found that bulging occurs up to the 2 times diameter, and maximum bulging up to the 2 times diameter, and it will lead up to the 4 times diameter, right? So Basak, Indra Ratna, 2015, that all references I have mentioned in my reference section, you can see that references, even though more detail on the failure study of stone column, right? However, in my PhD research, I have also found out by using Plexis software that how much uh, stone column is deformed at which depth, that I have also found out during my studies. But from many researchers, it is concluded that stone column is bulged up to the maximum up to the 2 times diameter. There is a certain technique you can uh, prevent this bulging by providing geosynthetic encasement. What is that technique? We will discuss later on after this slide. But here, a stone column may fail if there is a less confinement here, right? So this is the failure of stone column. How you can neglect, we'll learn in later slide. You see, once you apply load, a stone column is expanding here, but by using geosynthetic material, geosynthetic is a one type of fabric which is non-cohesive during the non-corroded, right? No weathering effect will happen on the geosynthetic material. Even though steel or any other material will be corrugated, but geosynthetic material will not corrugate. But this material is very helpful. How it is helpful? During construction of stone column, whatever we created borehole, you simply put that geosynthetic material into the borehole and then feed with stone aggregate. So what this help to reduce the bulging, that extra additional confinement, whatever the topsoil not providing confinement, that you can neglect by providing geosynthetic material, right? So geosynthetic will help you to provide additional confinement, so that whatever load coming from the top, it will travel up to the greater depth, right? So this way, the geosynthetic material will help you to transmit the load up to the greater depth and to reduce the bulging of stone column. Here you can see bulging will can be reduced by applying geosynthetics material. Many case studies we will later study later on, and which technique, at which places this technique is used, and which are the benefit, right? So in the railway project, in the embankment, whatever the stone column constructed here is for geosynthetic encased stone column. So whatever a soft soil, yellow soil here you can see soft soil, load coming over the stone column, it cannot bulge into the soft soil. So whatever load coming is transmit directly up to the hard soil. So it will help to transmit your vertical load up to the hard strata, even though stone is not bulging, because the geosynthetic providing extra confinement. So the bulging of stone column here by using geosynthetic material is reduced. Here one of the case studies is available, how we can construct the geosynthetic encased stone column. First, this case study is used in Brazil. The Husker company, like Keller company, Husker company also working in Brazil, so similar to the Keller company, a geosynthetic encased stone column, how we can create. So first you have to create the borehole, then inserting the geosynthetic material, ring track it is named, then feeding the aggregate. feeding the aggregate inside the hole, and meanwhile you remove the casing pipe. Once you up to say for example, once you create or feeding the aggregate up to 2 meter depth, the casing pipe may be uplift or lifting up to the 1 meter depth. Further adding material, lifting the pipe, further adding material, you can lifting the pipe. So this technique is very useful. This stone column technique, geosynthetic NK stone column, is very useful technique in the case of underground soil stabilization. Here you can see a vibratory probe is inserting into the ground up to the required depth. Then we feed the geosynthetic material inside the borehole. Geosynthetic material we are putting inside the hole. Once you provided geosynthetic, you have to feed, backfill with gravel or crushed aggregate. So whatever constructed stone column, later on we can provide the base at the top by creating the aggregate layer and geosynthetic layer, and then over that structure you can put the your embankment or whatever civil engineering structure we can put. So your settlement in the case of non-treated soil will be reduced in the case of geosynthetic and stone column. ઓકે સ્ટુડન્ટ બધાને દેખાય છે? મેમ પ્લીઝ કેન યુ રિપ્લાય? I am audible or visible my slides or not?
Yes, sir, it's visible.
Okay, thank you very much. So this is the geosynthetic NK stone column, and at field how we can create geosynthetic NK stone column. Over the ordinary stone column, geosynthetic stone column will help reduce bulging. It carry more load compared to the normal or uncased stone column. So limitations which is happen in the ordinary stone column creation, geotextile NK stone column we can use beyond the sensitivity for organic matter. If there is organic matter or clay, you can use geotextile material, because whatever confinement needed in the case of soft soil will provided by geosynthetic encasement, right? So whatever the limitations of soft soil, we can provide additional confinement by providing geosynthetic encasement, right? So this technique, geosynthetic NK stone column, is very helpful. Certain techniques also use if you provide geosynthetic material, fabric, or you provide casing of geosynthetic. Some of the research work also going on in laboratory, that you provide such casing so that the extra confinement you can create. So whatever soft soil, your stone column aggregate is penetrate into the ground, that limitations of ordinary stone column you can remove by providing extra confinement by means of geosynthetic encased stone column. You can see top slide that the procedure of stone column, geosynthetic encased stone column. Here at the bottom you can see the actual method for geosynthetic NK stone column. This technique widely used in the Germany as well as in UK. Husker Keller, some of the few companies, very big, huge companies worldwide providing geotechnical solution. This company having a large instrumentation which can create your ground improvement by stone column very quickly, right? So this technique compared to pile foundation, this technique will give you benefit in the case of saving project cost, because in one day you can create a total ground improvement. While in pile foundation, you need at least 30 days. If you put your pile material, concrete material, then you have to allow to settle, allow to harden the concrete. But in the case of stone column, you can create within 1 day. Your project will work. Your site will be neat and clean, right? So this technique is very beneficial compared to pile foundation. So this is again a picture of the geosynthetic NK stone column. How can we create? This is the finishing stone column, finished geosynthetic NK stone column. And first slide you can see the geosynthetic material here. Geosynthetic material at the top you have this borehole, whatever we created with the help of augering or with the vibratory probe, a casing pipe we need to install, and then geosynthetic material we have to install, and at the top of the geosynthetic material we have to bind at the top with rubber, and then feeding the aggregate at the bottom. Once the aggregate or whatever the stone column completed up to the ground surface, you have to remove whatever the binding from this casing with geosynthetic material. So your geosynthetic NK material, geosynthetic NK stone column we can create. Now talk about the various applications of stone column. In versatile stone column technique, geosynthetic NKs or whether ordinary stone column, we can apply at various civil engineering structures, right? It can be applied up to the soil which having sensitivity less than 4, sensitivity less than 4 OI. Up to that we can apply normal stone column, but if the sensitivity even though 2 to 4, we can apply geosynthetic NK stone column for the ground improvement. So here if we talk about various application, you can use stone column for the embankment, whether embankment for railway or for the highway, right? So whatever ground improvement needed, we can provide with stone column. After constructing the geosynthetic NK stone column, you have to put the top surface with non-cohesive material and create a level surface. During stone column installation, you cannot create the level surface at the top, but by feeding the non-cohesive material at the top surface, we are creating sand layer at the top. So leveling surface is required. So after that, you can create, you can lay down the geosynthetic material even at the top, and then you can lay down your embankment so that a settlement or undulation of the railway track or embankment will vary less, because you reduce your settlement here. There is a hardly 5 mm settlement if you construct this stone column effectively. So constructing with stone column will give you the less settlement at the site. You can use stone column even in the road embankment at certain spacing, certain diameter. You can create stone column even in the bridge abutment, because a middle portion of bridge which is RCC, but at the approaches which are earthen fill approaches, right? So in such cases you can create stone column, so your embankment will not fail by creating stone column at the sides of the embankment. Even this stone column technique is very useful to treat the offshore structures like seashore structure. If you construct the jetty or whatever the offshore structures, then a stone column ground improvement is very helpful. Otherwise, if you not construct the stone column, what happen? For construction of underground water, you create coffer dam, which is very costly compared to civil engineering cost. If you create coffer dam, which is very costly, But the stone column technique will treat the ground, even offshore ground, very quickly and effective means. Right. So here, stone column technique is used for logistic platform, railway platform at the Moita, South Lisbio. Keller company taken the project, Portugal area, around 6,700 stone column installed at specific depth, specific pattern with up to 60-meter diameter, 60-meter depth. Area is improved around 50,000 square meter. So whatever the area that stone column technique will treat easily and very quickly. So electric depth vibrator is used by Keller, which is very effective for creating borehole, right, and creating stone column. Bottom feed technique is used. Here you can see in this picture, bottom feed aggregate is feeding in the bore probe itself. Then we feeding aggregate inside the hole and compacting. This technique is very useful. This is the case studies where the stone column effectively provided. Another technique for the windmill, whatever windmill now we are seeing at the site, at the top, the foundation, we need to treat that soil by certain means. So stone column technique is very helpful in the case of tower like structure. Say for example windmill. Here you can see in graphical pictures a foundation for windmill is created in US state Nova Helitech company taken the project aggregate pier is created for the windmill. Vibro float here you can see used for the creating ground. Dry bottom feed technique used, cost effective છે. Plus this ground improvement we can create this such type of area around 50,000 square meter area we can create within 1 week, right? So ultimately your project timing will reduce. This is under case studies in New Zealand, Canterbury, stone column technique used, vibratory flow washed, the top wet feed technique used by creating borehole, vibratory probe with water jetting used, a top surface, at the top surface whatever the wet top feed method what we learn in the wet top feed technique, we apply aggregate at the top. Aggregate is travel up to the ground up to the required depth by means of water jetting and by means of gravity and by means of vibratory action. So a stone column resulting ground is placed with non-cohesive material. Whatever the cohesive material is washed out by this vibratory probe, water jetting, right? And a non-cohesive material which is very useful for reducing settlement is created with this vibratory action. Another case studies for the warehouse in France. This project diameter around 40 to 120 centimeter diameter use. The technique used vibratory probe, dry bottom feed technique. Here you can see used aggregate feeded into the hole up to the required depth and compacting by vibratory hammer. So such way you can put your structure. This is actual field where this stone column technique constructed. What are the advantages? The time of the project is reduced, even settlement is reduced, your site will be neat and clean, because there is no staking of reinforcement at the site, because you need to put aggregate inside the wall, so there is a neat and clean site. Within a week of 5,000 square meter, you can treat the ground very rapidly. Another application of stone column is you can create a stone column foundation for the LNG, oil storage tank, liquefied petroleum gas or crude oil tank. In Reliance Hazira LNG tank, stone column foundation is prepared. There is case study also available. But such technique, within a one day, you can put your tank over the ground. If you use pile foundation, then what happen? You need to wait for at least 30 days. While in stone column, you can put your structure within 1 week or after completion of the ground improvement. As that depend on how fast you can create the stone column. If you multiply the instrumentation, then your cost, your time of construction, even though very less. This is one of the applications, one of the case studies, that storage terminal station, Singapore, Jurong Island, is used. A stone column technique were used at the foundation of the such oil tank, oil storage tank. Yellow, dark yellow portion, here you can see a sand filled with vibro stone column. Over that, a 22.3 meter depth diameter of tank. You can create the stone column up to the 20 to 35 meter. Up to the hard set available, depend on accessories or instrument available with you at this site. So before and after installing stone column, you need to take certain test. Say for example, here CPT, cone penetration test, is carried out before construction. Here you can see the cone resistance is around 20 megapascal, but this cone resistance after installing such stone column, here you can see the CPT value is increased, is around 35 or more depth, right? So it reveals that by installing stone column, your ground is improved. This technique, whatever references I have mentioned, that also I have mentioned in references, you can study more by clicking these references. Stone column can be used for the slope stability actions, right? Whatever the failure of slope is in this pattern, so at the hill portion you can put stone column for the ground improvement, so the slope may not fail, right? Even in residential or commercial building, you can put the various stone column at design spacing or design pattern, design diameter, whatever we learned in previously. So this is the case studies where you can apply or you can do ground improvement using stone column. So before and after test is necessary, that you aware that how much improvement is taken place. Other case studies, location in Bihar, Keller company carried out this project for factory area. Owner, Madhepura Electric Locomotive Private Limited. Main contractor is Tata Project. Tata Project given this contract for ground improvement to the Keller company for creating the hard layer soil improvement. Keller has introduced stone column technique. The engineer was CIMEC consultant. So this project is constructed, ground improvement is created within 1 week. So whatever the time left during construction is very minimum in the case of stone column technique. Now we discuss various parameters or various researches going on in laboratory. I have created some of the slide, very few slide. If you learn about the various method or various technique, how you can did research beyond a certain whatever technique available in the field, even though this technique need to be improved by creating certain research, right? If you create some of the research in the laboratory, then this will very helpful for ground improvement and reducing cost. If you do some of the research in the laboratory, then this will very helpful to the society. So we talk about such research is that in laboratory research, what people are trying to find is by creating geosynthetic encased stone column, what people are doing, a tank, a tank which is filled with clay material, then whatever boring we are creating into the ground at site, that exact prototype you have to create at laboratory, and whatever the process you follow, you insert the stone column aggregate, geosynthetic encased stone column or ordinary stone column, and you apply simply load, right? So you have to measure whether stone column is settle at which load. So load versus settlement you will get. So you can conclude that the settlement, at which settlement, how much load the exact stone column will carry at the site. So few research is already completed by various scientists. Here I have reference provided. Rugation S 2020 and many others scientists have created this type of prototype at the laboratory and created exact prototype at the laboratory, applying load, how it is uh, carry the load at which settlement. You have to measure by LVDT and by the strain gauges. Here you can see strain gauges. Strain gauges will help that how much settlement at which depth is happen. Here you can see strain gauge is already available at this at the field. Uh, Available in market. Strain gauge you apply, simply put that strain gauge in stone column, and you can measure how much settlement is happen, right, at each and every depth. So this is the research going on. In that research, here you can see stone column is provided in triangular pattern. The diameter was 75 mm. The length and width is 1200 mm, right? And depth, according to in previous slide what we have seen, 600 mm depth tank is used, and a certain loading arrangement, loading plate you have to put, and over that you have apply load. So by applying load, whatever the settlement at which load, you have to find that graphical presentation you can put during your study if you interested in such type of uh, practical work in your master degree. Here, this type of research work is already completed. You need to take something different parameters. By considering field experience, you can reduce cost, you can reduce time by providing certain arrangement, by providing certain technique, right? So this way you can uh, give your contribution to the society by providing different research in this field, stone column technique. Other researchers have also created such type of laboratory uh, arrangement, right? Loading frame and tank, created stone column, applying load. You can place different type of soil even for the uh, stone column, at which uh, soil parameter available at site, at which technique is useful, right? Different type of soil you can treat. But uh, I can tell you that this soft soil creation and its management in laboratory is very tedious. If you use silt and sand, then your job will very easy. But if you create this tank filled with soil, clay, then there is very tedious work, right? Clay, always treating clay is very difficult. Meanwhile, playing with clay is very difficult because silt will create the bed very easily. but by creating clay layer is very difficult in the sand. So by considering such parameters during your research work, you further think about which type of soil bed you need to prepare. If you prepare clay bed, then your job will very hard. During my research work, what I have done in triaxial testing machine, I have put certain cylinder, hollow cylinder. In that, I have created the clay layer, right? Clay. So clay layer is treated with geosynthetic encased stone column. Here you can see in systematic diameter this diagram. I have created stone column, then putting the loading plate and apply load. So load versus settlement for ordinary stone column. Ordinary, that means no geosynthetic encasement is provided. You put your loading over the stone column and measure the settlement. So I have did this research in S180, a very useful technique, stone column. In that I have find out that the stone column depth is need not to increase further depth, because the stone column depth is mostly useful up to a certain depth. Beyond that, if you increase stone column depth, is not useful, is further increase your project cost, because depth of stone column is directly related to your project cost, right? So depth, I have find out that critical depth, at which critical depth the stone column must be installed. Beyond that, there is no improvement of ground, right? If 15-meter ground improvement, 15-meter depth stone column is required, why we would create the 20-meter depth stone column? So such research, even you can create. This is my research work I have shown here. Loading arrangement, loading cell and LVDT. I have attached, then apply load. It's different condition. I have uh, uh, tested almost 700 times by creating this clay layer and applying load at different conditions. Ordinary stone column by different depth, different diameter, by providing ordinary or by providing geosynthetic. Right. Then I have created the graphs. Here you can see in my research, uh, this is ordinary stone column with 45, 50, 55 and 60 diameter. You can see stress versus settlement curve for ordinary only clay without treating soil. That means we have not treated soil with stone column. Only clay is there. You can see a stone column which is carry only 400 kilopascal load. Okay. So this type of research you can create. Laboratory research work also going on. Its presentation I will share you presentation. Even though in software you can use Plexi software, Midas General, Midas Geotech, various software is available. You can create or simulate models. By concluding this session, I can tell you that stone column technique is versatilely used, very quick, right? It reduce settlement, mitigate liquefaction, more economical, no waiting period, homogenize soil. That means we homogenize soil with non-cohesive material, no dewatering required, reduce overall project cost, reduce time. So these are compared to other technique, pile foundation, a stone column will give you ground improvement within 1 week. So your project cost will reduce. So these are the reference. You can go through such references I have mentioned during my presentation. Thank you all for your kind attention. Now I hand over to the Professor Damayanti ma'am. Please.
Thank you so much, Himmat sir, for such a nice presentation. I would like to request my coordinator to please proceed for a vote of thanks to our eminent speaker, and please take lead for the third session.
Thank you, Sarvaiya sir, for such a nice explanation of the stone column concept. Uh, Sir, your lecture was wonderful, and our participants learned a lot from it. I take privilege to say my thanks to you on behalf of all the participants for this lecture. And I would also like to thank the Vidyapati Trust Principal, Sir, Department Head, and TNP officer and organizer, Dr. Damayanti, for organizing this event. I would like to thank all the faculty members for their help in support for successful execution of the program. Uh, Thanks to the audience and participants who have enjoyed this session. And I would also like to uh, thanks to Nikun sir who has handled this session. So, sir, we are very thankful to you for conducting this session and imparting us a lot of knowledge on stone column and why is it important. Thank you, sir.